Euclid's book 1 proposition 45 says that given a rectilinear figure and an angle, we should be able to draw a parallelogram whose area is equal to this area of the rectilinear figure, and one of the angles is the given angle. So let's see how we can do that. So let's draw a line here AC, connecting AC, so that we end up with two triangles. And now we take these triangles one by one. So let's convert this BC into a line. Now we have to figure out the midpoint. We know how to do that, and we have got the midpoint here. So let's hide off this. And now at G, we have to copy this angle. So let's do that. Circle at G of radius HI. Circle at G of radius HJ, the intersection point of the line with the circle, and a circle with K as the center and radius as IJ. Now we take the intersection and we connect these two GL to form a line. So now this angle is equal to this angle. Now what we'll do is we will draw a line parallel to BC at A. So let's first hide off these circles. So let's draw a parallel. We basically copy this angle to A, so that alternate angles become equal and the line that we draw would be a parallel. So this was a circle with A as the center and BC as a radius. Now we draw a circle with B as a center and AC as a radius. And we take the intersection point. There are two, but we are interested in this. And we join M and A. So now we have got the parallel lines. This M also we don't. Now this line and this line intersect each other. So let's mark that point of intersection. Now we have to again copy this angle to C. Or in other words, we have to draw a line parallel to this line at C. So again, we copy the angle so that now it is the corresponding angles that are equal, which again makes the two lines parallel. Okay, so let's hide off these circles. And again, we need the point of intersection of this line with this line. So yes, and now we don't need these lines. So now we have got a parallelogram whose area is equal to the area of this triangle. Now we repeat this with respect to triangle ACD. Okay, so which means we start off with extending CD. Midpoint is required. So we have got the midpoint here. So let's get off all the unnecessary. T is the midpoint of CD. Now we have to copy this angle here at T. As you notice, this is pretty repetitive task. Again, we have to draw a line parallel to this line at D. So again, let's hide these circles. Again, circles. So we have got the parallel line. So let's hide these circles. Now we have to draw a line parallel to CD at A. So again, we know how to do that. Let's hide these circles. And now let's look at the intersection points of these lines. This line and these two lines. Of course, we don't require these points. Okay, let's mark the points of intersection. So now this parallelogram area is equal to the area of this triangle AC. Now let's hide off these lines as well. Construct a single parallelogram whose area is equal to the sum of these two parallelograms. So let's start off. Let's mark a point and let's mark another point and let's connect these 2 points. Now it doesn't really matter where these points are, could be anywhere. Let's extend it in both the directions. Now keeping the center at D1, let's draw a circle of radius QC. QC, one of the sides of the parallelogram, NGCQ. And we mark this point of intersection. So now D1 F1 is equal to QC. Okay, now we don't need this circle. Now at D1, we have to copy this angle. So again, we know how to do that. Right? So let's hide off all these. So this angle is equal to this angle. Now what do we do? Now we draw a circle at F1 of radius GC. Again at D1 of radius GC. And let's mark the point of intersection of this line with this circle. Now we don't really require H1. We draw a circle at D1 of radius GQ, the diagonal, and we identify the intersection point of these two circles and we join these 2 points. Let's connect these points and we draw a circle at E1 of radius GC. So of radius GC, we are constructing these 3 triangles. Okay. And now we look at the intersection of this circle with the line that was drawn connecting these two. Okay. You have to choose the correct intersection point. So let's connect all the points so that I can remove these lines. And now let's remove these circles as well. So I've got this. Do you remember our actual parallelogram equivalent to this should come along this line. So that means we have to come out with the complement of this parallelogram. So what do? We join K1, D1 and extend the line, that diagonal, yes. And we have to draw a line, or rather we have to extend this line J1, F1. We have to extend I1, D1. We have to extend K1, E1. So now if you notice, this diagonal intersects J1, F1. So let's mark that point of intersection. And we basically draw a line parallel to F1, E1 at L1. So we know how to do that. So now let's join those points. This is our required parallelogram with respect to ABC. Now we treat this as the given line, that is M1, N1. And we create a parallelogram which is equal to this parallelogram. Okay, so let's first of all hide this line. Okay, and let's start. What we do? We have to extend this line 1 and 1 so that M1 and that point would be equal to this side of the parallelogram. Okay, extend that line, mark the point of intersection, join those 2 points. Now just focus on the green colored lines. And now we don't require this line and we don't require this circle. So we have got this line which is equal to DC1. We draw a circle at M1 of radius TD and we draw a circle at O1 of radius DB1 and we look at the point of intersection. And now we draw a circle at M1. Now we draw a circle at M1 of radius TC1 and we draw a circle at O1 of radius TD. Now just mark the points of intersection and join the points. Okay, now let's hide off all these circles. It really clutters up the diagram. Okay, so now we have got this line. Now we have to join this also. So draw a circle at N1 of radius TD and mark the point of intersection with this line. Okay, join these lines and draw the diagonal. R1 M1 diagonal and extend Q1 O1. Now look at the intersection point of this S1. Now we have to drop this. So circles, points of intersections, connecting the lines, and now let's hide these circles and we get this polygon. So this parallelogram is equal to this parallelogram. This parallelogram is equal to this parallelogram. This is equal to ABC. This is equal to ACD. That means ABC plus ACD is equal to this parallelogram plus this parallelogram. And one of the angles is the given angle. Let me mark those angles. So we have taken a rectilinear figure and a given angle, and we have constructed a parallelogram with the same area as the given rectilinear figure. Now what's the fun? Remember I told you it doesn't matter what size this segment is and what the orientation is, it will always be equal. Similarly, you can change the size of the rectilinear figure. You can change this. The areas will always correspond. Now, just to make sure that you understand that that is actually the case, watch this. The given angle JHI is 57 degree. E1 D1 M1. E1 D1 M1. This angle is also 57 degree. N1 M1 D1. This angle is also 57 degree. Angle CGN, this angle is also 57 degree. Angle DTB1, that is this angle is also 57 degree. So all these angles are 57 degree. Now look at the area of the triangle ABC is 2.74. I said that the area of this parallelogram will be 2.74. D1 E1 is also 2.74. Area of ADC, this triangle, is 5.97. And M1 N1 U1 T1, M1 N1 U1 T1, that is also 5.97 units. Again, just watch. Exactly same. Those values don't change. Now look at what happens when I change the angle. All the angles are changing, but the areas are not changing. Now let's change the ACD. You see, it remains constant. It remains same. Similarly, if I change this, these two areas remain same. So that is book 1, proposition 45. Again, let me remind you, there is a link to a PDF book which describes all these propositions that I have been discussing. That's it for now.